Today's question, a programming interview question, is called array pair sum. Before we get into the question, I want you to think good about techniques and tips for programming interviews. What do I mean by thinking good about tips and techniques? What I mean is that you should look at the question and note what you have. If in the question you have an array, as we have here, then you should immediately know that scanning this array takes O of n, and this is a possibility in your solution. You should take into account scanning. The second thing to think about arrays is that you can have multiple ways of scanning the array. If you have an array, you can scan it like this by having a pointer, let's say p1, starting at index 0 and moving forward, or maybe you could have two pointers, each scanning in its own velocity. So pointer 1 is it scanning at velocity x1, pointer 2 is scanning at velocity x2. So we already have a few techniques about solving this question without even knowing this question, right? So we are in a very good position. Let's see which other techniques we already know about this question before solving it. We know it is an array, right? This is the same thing. We know it is an array. And what can you do with an array? If it's an array of integers, then you could, of course, sort it. You could massage your input data. So if I have 2, 1, 3, 2, 4, I could sort it 1, 2, 3, 4. And this I know takes O of n log n. So we already know something about the time complexity, which we could apply techniques into solving this question now. Let's move on and find some more definitions about the question. Remember, we didn't even ask the question and we already have solutions. So let's start by asking a few questions. I mean, let's see what's actually the question is for this problem. So the question is to find pairs of sums. So if we have an array of size n, this is the size of the array, we are given another number which they call in the question is named k. And the question is to find all the pairs which sum up to k. So let's take an example. We have this array 1, 3, 2, and 4, and let's say, so here of course the size is 4, so n is 4, and if we are given k which is 3, then which pairs give us a sum of 3? So we have 1 and 2, and at this point ask your interviewer whether 2 and 1 is another solution or not. Okay, so we have 2 or 1 solution, and the problem definition was given an array of size n, find all the pairs of numbers which sum up to k equals 3. So we have much more details. Let's see which other techniques we can apply. So we already said we could sort it. We could put the items, as always in programming interview questions, you can just put them in hash map. So you could put them in a hash map or a hash set or a set. Yeah, you can put all these items in a map or a set, right? And you can have pointers as we have shown. You can do more things, but we have already a few techniques. Now, given these few techniques, how can you solve the question? The first thing I would recommend you to do is to go with the brute force. Why? Because going with brute force technique means you get more familiarized with the question which is asked of you, and you are already giving a solution. Now, although this solution will be very bad in manners of time complexity and memory complexity, I insist that you mention it and mention that it is a bad solution, and you do it only for massaging the question and understanding it better. So a quick brute force solution would be to find all the pairs would be simply to take one item. Let's say we take the first item and then we scan all the items, and for each one we check whether its sum is k. So if our k was 3, we take 1 and 3, they sum up to 4, so no. We take 1, same number, and 2, yes, they sum up to 3. Good, we have an answer. We take 1 and 2, so we take 1 and 4, and we get 5. So no, so we have one answer, and in this case you should mention that the time complexity for this would be that you scan all the items, but for each item you need to scan all the other items. So you have here n for the first item, because for the first time you scan all the items, so it's n because the size of the array is n. For the second item you again scan all the items, maybe including the previous one depending on question or not, but you scan all the items, so it's n times n times, for each number you scan all the array, so it's n times n, which is n squared complexity. Good, so we quickly went through the problem and found a brute force solution. Let's move on with the next solution proposed. We said that one of our techniques was to sort the array. So let's sort it. So if we sort the array, we get this array, and now we need to get to the number 3. So you see, if we add these two numbers, we do get to the number 3. Now notice that if we move on to the right and add to the number 1 other numbers, they would be bigger than 3, because 1 plus 2 is 3, 1 plus 3 is bigger, so we don't have any reason to move to the right. Let's think of it from another angle. We have a pointer here to the number. Where would you like to place the another pointer but save time? If you want to save time, you could place another pointer here, and if the sum of these two is already bigger, remember this is a sorted array, this is very important, sorted array. So the numbers on the left are smaller than the numbers on the right. So if we add these two extreme numbers, if it's bigger than k, what should we do? We should find a number which is less, which is lower. So we move only the p2 pointer. Still bigger than k? There is no reason to move pointer 1 to the right, because we'll only get a number which is yet another number which is the sum of these two pairs bigger than k. So we move the pointer 2 again to the left. Bigger than k? No, in this time it's 3, so we are equal to k. So you see, we just move the two pointers to the left and to the right, and we find all the pairs which are whose sum of pointer 1 and pointer 2 is equal to k. And what is the time complexity of this? The time complexity of this would be, we had to scan here the array at the end, and we had to sort it. Sorting is n log n, the best sorting. Okay, so we could simply say that we have an n log n complexity for this problem. So good, we found another solution. Let's look at these techniques and see if we have another solution. Let's choose this one. What if we put all the items in a set? Let's put them in a set. So if we put all the items in a set, sorted or not sorted, then we have this set. Let's choose an item from the set. Let's scan the set. We now scan the set. We choose an item. We have chosen the number 1. How can we know if there is a number in the original array whose sum is 3? Well, we simply need to do set dot get which number 2, because if there is 2, then the sum of these would be equal. If there is none, then we don't have any number with whose sum with 1 would be equal to 3. So if we put all the items in a set, we could simply scan item by item, and for each item find its complementary to the k. So again, a very cool solution. The time complexity would be, of course, filling up the set, which is n, could be n, and then finding for each item whether its complementary is there, which is O of 1. And of course we need more space, because we need O of n space to store the set, to store the set. So we have 3 solutions. 1, brute force. 2, a technique with 2 pointers, P1 and P2, after another technique which is sorting the array and hash mappifying it, or set, or putting all the items in a set. Remember, sometimes you don't need just a hash map, you could simply use a set for the items. Now when we get on to writing the code for this, let's say I'm going to use Java. So when you write the code, you should remember a few nice things. First, that you have the arrays object in Java, which you can call a few methods. For example, you can call arrays.sort. This is going to be very useful for our second solution, which uses sorting, and give it some kind of array. It will sort it and change this array. So you don't need to re-implement the sort. If the sort is not the core of your problem, you simply call arrays.sort. But to call arrays.sort, you need to remember there exists such a method. So you should remember this. Another thing to remember is that when you are printing the array, instead of looping the array and printing, what you should do instead is call again arrays. And you call dot to string, and if you need to print the array, you simply call this method. You don't need to loop it. And with that, let's move on to the code. So in the code we have our main method, so let's call it main. I won't write all the public static main. Okay, and we define our k, or get it as a parameter. So our function find per sum would get 2 parameters, the array and the number k. So we have, and it will return the list of the pairs of items. So you can return of set of int and int. Okay, now that we have it, let's start to write it. So we are first sorting the array. So remember, we call arrays dot sort array. Now we have the array sorted. Let's create our two pointers. Pointer number 1 is pointing from index 0. Of course, you should check. I'm skipping this, but check the size of the array, check the cage, validate everything. This is not the focus of us. But it's very important. You should always validate. We have pointer 1 pointing to 0, and we have pointer 2 pointing to arrays dot length, so it's pointing to the end. Okay, and now we compare simply whether our two pointers are pointing to two different items. So as long as pointer 1 is not pointing to the same items, remember, we are making sure that we have the pointers, we did not get both of them to the same item. So as long as pointer item is not equal to pointer 2, then we simply record what is our current sum. As long as they are not equal, we are simply writing the current sum. So current sum is array of location P1 plus array of location P2, and then if current sum is equal to k, we add it to the list of k or print. So we print the numbers array P1, and we also print array P2. This is partly pseudocode, partly Java because of the lack of time. And if the core sum is less than k, else if core sum less than k, simply increment pointer 1, else P2 minus minus. And this is it. We simply compare the two pointers, make sure they are not pointing to the same item, and then we have the current sum, which is where the pointer 1 is pointing to and pointer 2 is locating to, and we calculate the current sum. We check if the current sum is k. If it's less than k, we increment pointer 1. If it's more than k, we decrement pointer 2 until they are the same. If the sum is k, we are printing it, and we're also incrementing maybe one of the pointers, P1 plus plus, it doesn't matter. And this is it for today's interview question. I hope you enjoyed it, and I will see you next time. Please feel free to comment and suggest. Thank you for listening.